Hi, my name is Ahmed Al-Harbi and today I'll be presenting our research paper titled NPS-AntiClone Identity Cloning Detection Based on Non-Privacy Sensitive User Profile Data. Social sensor can publish thousands or even millions of data in the form of text and images over social sensor clouds. Social sensor can be social media post or human as a sensor. The sensed data is hosted in social sensor clouds, which can represent social networks such as Twitter and Facebook and can take different shapes. Social sensor cloud services can help describe events from different perspectives, such as where, when, and what through the functional and non-functional properties of social sensor cloud services. The popularity of social sensor clouds has attracted many attackers attempting to exploit social sensor service providers' identities and deceive users in many ways. Identity cloning is one such mode of deception, whereby an attacker registers a fake user profile and exploits the user's identity information to perform malicious activities. Identity cloning can take two key shapes in the form of single-site and cross-site identity cloning. The single-site refers to an attacker creates a cloned identity of a social media user in the same social media platform. The cross-site identity cloning, where an attacker clones the identity of a user from another social media platform. In this work, we will focus on a single-site identity cloning detection. Examples for such malicious activities including ruining the account's reputation or deceiving the account's friends to steal sensitive information that is not publicly available. For example, in 2018, it has been reported that the Facebook account of Mark Zuckerberg, Chief Executive Officer of the Facebook, has previously been cloned and involved in financial fraud. Another well-known example is that in 2018, Russian President Vladimir Putin's Twitter account was cloned and attracted over 1 million followers. Moreover, these fake identities can also be used to spread fake and false information sourced from unreliable source rapidly. This can negatively impact thousands of individuals since most of individuals tend to believe the information published on social media in regards to public events. Now I'll present the related works. A significant number of approaches had been proposed in the current literature to detect fake identities or spammers on social media. Behavior profile features are not optimal to detect identity cloning, since an attacker trying to clone the identities can mimic their profile attributes. Most of social media lack automated support for detecting identity cloning, or, for example, Twitter and Instagram review identity cloning claims upon receiving a valid identity cloning report from the end user. Currently, these platforms do not have support for automated tools to detect identity cloning. Furthermore, most of the existing studies relies on both privacy-sensitive and non-privacy-sensitive user profile data. Privacy-sensitive user profile data is not publicly available, cannot be accessed by third-party applications API or other means due to privacy restriction. An example of this data is a full name, date of birth, or personal photographs. However, non-privacy sensitive user profile data is publicly available and can be accessed by third-party application APIs. An example of the non-privacy sensitive user profile data is screen name, profile description, and number of friends. Most of the existing studies detect identity cloning based on both privacy sensitive and non-privacy user profile, and most of them use simple feature similarity, and supervised machine learning. Simple feature similarity such as TF-IDF and Jaro-Winkler, these metrics enable to capture the semantics of various literal strings, and it only focus only on characters distance or word frequency. For example, they cannot measure the semantics between the words king and man, which describe a gender-based relationship. Moreover, existing work uses supervised machine learning, which requires labeled data samples for predictive model training. In addition to that, it's time-consuming and needs high labor cost to obtain enough labeled data samples to train machine learning models. Our work employs only the non-privacy-sensitive user profile data, which are accessed by social sensor cloud APIs. In addition, our work focuses on learning social network users' multi-view representation. The multi-view information describes the social user's profile from multiple perspectives, which can be used to complement the incomplete profile information. Furthermore, our approach aims to be used for third-party websites or applications to perform identity cloning detection based on social media APIs, since they often use social media accounts for authentication. Now I will present our proposed solution, NPS-AntiClone. First of all, we need to generate suspicious account pairs for identity cloning detection. Therefore, we adapt a mechanism commonly used in the existing works, whereby we search for a pair of accounts that contain a similar username or screen name. The overview of our proposal is shown in this figure. Given a set of social media accounts, we aim to detect identity cloning using multi-view representation of an account. Firstly, we generate different views based on post, network, and profile attributes for a given social media account. We then use WGCCA to learn a single embedding from all these views. We then calculate the cosine similarity between an account pair to predict whether or not it contains an account and its victim. First step in our proposed solution is a multi-view account representation model. Our goal is to generate a multi-view account representation for a given user account by combining several views that correspond to the non-privacy sensitive profile data of the account. Therefore, we use three different views based on the account's post view, network view, and profile attribute view. First, the post view, we extract a pre-trained language representation for each account using the sentence paired, and we compute the mean of all the post representation to get an aggregated post representation. This figure shows the architecture of a paired. Second, the network view. We consider two types of account networks, follower and friend network. In the follower network, if an account follows a specific user, such as a celebrity or a friend, there will be an edge between them. In the friend network, if an account gets a follow by another account, there will be an edge between them. Inspired by the success of a graph representation, we utilize the node Tawfiq to learn the network representation, or in other words, network view of an account. Node Tawfiq can learn the high-level feature representation that include deep social interaction of accounts. For the final view, profile attribute view, we extract 12 public profile attributes of an account to create an attribute vector. These attributes can categorize the activities and reputation of an account. For example, the number of tweets can indicate the activities of an account, while the number of followers can indicate the reputation of an account. Here is the list of all profile attributes. In the second step, embedding layer model, the views described before include some knowledge that might be utilized to detect cloned accounts. However, employing only a single view might result in the loss of valuable information. A simple and naive technique is to combine all these views by combining them together. However, a drawback of this technique is that it will generate a very large account representation. It might also describe the complementary existence of the knowledge included in some views, such as the network view of an account. Therefore, we use weighted GCCA, which adds weight for each view. In the final step, in the prediction model, we use the cosine similarity to compute the similarity between the account pair. Now I will talk about our evaluation. Our evaluation consists of three tasks. First, parameter tuning. Second, comparison with existing identity cloning detection approaches. Third, comparison with supervised machine learning models. Dataset, we collected 4,030 public Twitter accounts, 2015 cloned accounts, and their corresponding victims' account. We also randomly collect 20,152 non-cloned public Twitter accounts to add noises to the dataset. In total, we have 24,182 public Twitter accounts. This table summarizes the detailed statistics. Here is the result of our parameter tuning task. First, we studied the impact of the multi-view representation, and we found that combining all proposed views improved the performance of the final proposed model by 13% in terms of F1 score. Moreover, we also experimented with an alternative way to combine all these views. In that, we combined all the views into a single account representation, and we found that our proposed solution outperforms the combined views by almost 20% in terms of the F1 score. The performance result indicated that the layered account multi-view using WGCCA can benefit the identity cloning detection by improving the performance. We also performed multiple rounds of an experiment to study the impact of the weight of the WGCA on each view. To do that, we tested different combination of weight, example 0.25 and 0.5 and 1 for each view. This figure shows the top 10 results observed against different combination of the weights. Our proposed solution depends on the cosine similarity score to decide whether one of the counts in a given account pair is cloned or not. Therefore, an important question this raises is how this similarity score impacts the performance of our proposed solution. This figure shows the performance result of our based on different values of the cosine similarity score, which shows 0.1 as the optimal cosine score. Second task is comparison with the existing identity cloning detection approach. The result of the experiment shows that our proposed approach clearly outperforms the existing state-of-the-art identity detection techniques, including the spammer detection techniques model as shown in this table. Our proposed approach outperforms all existing approach in all evaluation metrics as shown in this table. Final task is comparison with the supervised machine learning model We compared our proposed solution against a comprehensive set of supervised machine learning models, and the comparison result among our proposed solution and the other machine learning and deep learning model revealed that our proposed solution significantly outperformed all supervised models as shown in this table. In conclusion, we proposed a novel unsupervised solution identity cloning detection approach based on non-privacy sensitive user features. We devised an approach to automatically generate a multi-view representation that can comprehensively describe an account from a post view, a network view, and a profile attribute view. We adopted a technique that effectively learns a single account embedding from all the multi-view account representations. Our proposed solution was evaluated on a real-world Twitter dataset against other state-of-the-art clone identity detection techniques and supervised machine learning models, and the result shows that the proposed approach significantly outperformed the other models. Thank you for listening.